Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 678, valid parenthesis string. Given a string is containing only three types of characters, open, close parenthesis, and also a star. Okay, and we want to return true if the s is valid. So what is mean by valid string? So see here, any left parenthesis must have corresponding right parenthesis. Any right parenthesis must have corresponding left parenthesis, and left parenthesis must go before the corresponding right parenthesis. So this is going to be the important thing. And also star could be treated as single right parenthesis, single left parenthesis, or empty string. Okay, for example, see here open parenthesis and close parenthesis, so it is obviously true. Yes, and then here open parenthesis star close parenthesis, here I will be taking the star as empty so that it will be equal to this first example, so I will be returning true. Okay, see here open parenthesis star close which means here I will be taking the star and treating it as open parenthesis such that two open parenthesis and two close parenthesis, that's it. So the answer is what? True. Can you understand this? Okay, let me give you some more examples. See here, whether it is a valid parenthesis, no. Okay, now whether this is a valid parenthesis, no. Okay, tell me whether it is a valid parenthesis. No, because opening parenthesis should be at first, but here the closing parenthesis come first and opening at last, so this won't lead to be a valid. Can you understand this? So this is what the valid string they have given in the problem statement. Okay, fine. So how we are going to do this? So here the main objective and the main thing that plays role is this star. Yes, because see here this star can be transformed into three things, right? So just put the combinations and check whether it is a valid or not, that's it. Okay, so that's going to be my brute force approach. So just go with all possible combinations, which means go with recursion. What I'm telling you is go with recursion. Okay, for going with recursion, what are all the parameters I need? Okay, so this video going to be lengthy because I want to give you three approaches. Okay, so that's why it is going to be lengthy, and at the end you can clearly understand this. That's my guarantee. Okay, so see here, first of all, this function will be taking three parameters. So the first parameter going to be the index, the current index. Okay, and the next parameter going to be how many opening brackets are there as of now, and next one is how many close brackets are as of now. Why I need open and close brackets? Because when I am going like this, okay, at this particular point, when I am reaching at this particular point, I can tell you that it becomes false because there are only two open brackets in front of them, but there are three closing brackets after that. That's how I can tell you that it is false condition. For that reason only I am taking the open and close as a parameter. Okay, fine. So let's get started. Initially I will be starting from index number 0, and initially the opening bracket is 0 and closing bracket is also 0. Okay, so which means I am standing at this particular point. Okay, fine. So what is this? It is opening parenthesis. Whenever we encounter the opening parenthesis, then what we will be doing? Just go to the next function call, like go to index 1 and take opening as +1 and closing as it is. Can I understand now? Yes. Now what is the next thing? It is hash rich. Whenever it is hash rich, we have three combinations. So what are the three combinations? The first thing is it can be acting as a opening parenthesis. So if it is acting as an opening parenthesis, then it will be always the index will be +1. Okay, whenever there is a function call, and opening will become +1, which means 1 + 1 is equal to 2 and 0. What is the next combination? The next combination is I will be taking that as a closed. So 1, 1. What is the next combination? It is don't take anything. So here comes 2. Okay, don't take anything. Either neither it is not a closed or it is a open. Can you understand this? So these are the three combinations. Fine. So let me paste that here. Fine. Now let's get started. See here. Now I am at where? Second index. So what is second index element? It is closed parenthesis, which means here it will be f of go to third index in the next function call and take open bracket as it is, but close bracket will be +1, which is 0 plus 1 is equal to 1. Here it will be go to third index and take the opening bracket as it is and close bracket +1. Here it will be take the index as +1 and then opening bracket as it is and close bracket +1. Now see this carefully. What does this condition leads to? It is like opening bracket is greater than the close bracket. So from this I can tell you that I will be returning a false. Can you understand this? Here itself I will be returning false because it is not a valid thing. So here itself I will be returning false. Let us finish this, then come back here. Okay. Now here it is in a third index. So third index is again what? Close bracket. So here it will be like 4, 2, 2. Okay. Here it will be like 4, 1, 2. Again here the close bracket is exceeding the open bracket. So here I will be returning false. Okay. We shall come back again. Now just concentrate here. Now fourth index is open bracket. So here comes go to the fifth index and increase my open bracket and close bracket as it is. Okay. Now again it is open bracket here, right? Again it is open bracket. Okay. Now here comes f of 6 and open bracket +1 close bracket as it is. Now go to the sixth index. So sixth index is again asterisk. Whenever it is asterisk, what I going to do? I have 3 possibilities, right? So let me paste here. Okay, now I am standing particularly here. Okay, now I have 3 possibilities. So first possibility is go to index number 7, which means index +1 and treat as a open bracket. Okay, now treat as a closed bracket. Now don't treat anything. Just treat as a empty string. Okay, empty string. So that's going to be better. Okay, now come here to the 7th index is open bracket. So here comes what? Go to 8th index and increase my open bracket and close bracket as it is. Now come here, go to the 8th index and increase my open bracket and close bracket as it is. Now come here, go to 8th index, increase my open bracket and close bracket as it is. Hope you understand this. Now go to the 8th index. It is what? Close bracket. Close bracket means what I am going to do? Go to the 9th index, 6, 3. Here comes 9th index, 5, 4. Here comes 9th index, 5, 3. Again in the 9th index, it is again a closed bracket. So closed bracket means here comes 10, 6, 4, and here comes 10, here comes 5, 5, and here comes 10, here comes 5, 4. Okay, that's it. Now what is the 10th index? 10th index is nothing. 10th index is nothing. So at this particular point, what should I do? I will be finishing up. Okay, finishing up because I have came to the end of the string. Now check whether the opening and the close bracket are same here. No. So here I will be returning false. Check whether the opening and close bracket are same. Yes. So here I will be returning true. Here no. So returning false. So here this function will be returning false. Here it will be returning true. Here again it will be returning false. Here it will be returning true. Here it will be returning false. And here it will be returning false. Again here what I should take? See here, I have transformed the asterisk into 3 different forms. If any one is valid, then I can tell you that the function also valid, the string is also valid. So here it will be returning what? True. Can you understand this? So false, true, false. So any one valid, then it will be valid. So that's the reason I am returning true here. Here also true. Here also true. Now here also true. Okay. Now when it comes to the top, here also it returns true, it returns false, and it returns false here, and it returns false here. So what is the best possible answer? It is true. We got one thing as true. Okay, so return true. Again from here it will be returning true to the called place. Okay, so what is the answer? It is true. Can you understand this? So this is going to be the entire recursion tree. Okay, afterwards we can see the code for this. Before that, please try to implement this code because it is so simple. Fine. So this is what the recursion approach. Okay, now let us go with the second approach. Before that, let me tell you what is the time complexity taken here. The time complexity will be over 2 power n, or maybe it of 3 power n. Okay, because if the string itself of total of hashtags, so n hashtags, then it means for everything we have three different variations. So it will be 3 power n. That's the reason why time complexity is 3 power n. And what is the space complexity? It will be O of n. Here most of them will be confused with the space complexity and writing here as 3 power n. Okay, no, because always the recursion will be of DFS. DFS means it will be going for the left call and finish it away, then only it comes to the next call, finish it away, then only it goes to the depth of the right call. Can you understand this? Okay, if you want to know about the recursions, I have recommend you to watch my recursion basic playlist, where I have just thought about what is meant by recursion and recursion tree and recursion stack and how the recursion works. Okay, because many of them don't know that recursion works in a DFS manner. So I'll be giving that link in the description. Just go and watch it. It will be more helpful when you are going for a non-linear data structure. Fine. So that's it for the first approach. Now let's get optimized. So recursion. In recursion, we use stack data structure, right? Inbuilt stack. That will be inbuilt stack. That's the reason why we are getting here as O of n. Similarly, can we solve this problem using stack data structure? Instead of going for recursion, can I solve using the stack data structure? Okay, let's consider this string again. Okay. Now, just listen this carefully. I want you to understand these things. Okay. So, whenever there is a opening, I will be pushing into the stack. Whenever there is a closing, at that particular time, I will be popping out the opening inside the stack. And also there is a hashtag that plays an important role here, right? So hashtag may be of open bracket, may be of closed bracket, or it may be empty. So hashtags play an important role also, right? So my design for this particular problem is I'll be taking one stack and another stack. So this stack will be of opening and close parenthesis, that handling. Okay, so this is stack 1. This stack 2 is especially for star, these asterisk purpose. Okay, I'll be giving you the algorithm. Just try to understand that logic and implement the code by yourself. Okay, try to understand this intuition. See here, first of all, I am standing at this particular point, the opening parenthesis. Okay. Now, whenever it is an opening parenthesis, I'll be pushing into the stack the index, 0th index. Okay, because see here, whenever there is an opening, again whenever there is a closing, I can tell you that it is one of the pair and I will be cancelling out. When in future there is another closing bracket, then I will cancel this and this. So this same logic is applied here also. That's the reason why we are going with the stack data structure, because we want the recent values. Okay, so 0 is inserted here first. Okay, now here comes star. Whenever there is a star, insert in the S2, that stack. I will be telling you why we are using this S2. So here comes 1. Okay, now close bracket. Whenever there is a close bracket, we want to check whether S1 is empty or not. Yes, S1 is not empty. Whenever S1 is not empty, just pop the top element in the stack. Whenever we encounter the close bracket, okay, again we are encountering the close bracket, but unfortunately S1 is empty. In this particular case, what should I do? I will be going and checking whether I have any star before me. So that I will be converting that star into a opening bracket. So see here, S2 is empty. No, S2 is not empty. So this one is popped out. Can you understand this? Yes. Now go to here. It is what? It is opening bracket. Again, what is it in this? It is 4. Insert here. Again, go to the further thing. So here comes 5. Insert here. Again, here comes star. So insert here. Okay, again it comes open bracket. So here comes 7. Now here comes close bracket. Whenever it comes close bracket, just pop it out after checking whether S1 is not empty. Yes. Again it is close bracket. So check whether S1 is not empty. Yes. So pop it out. Now that's it. Finished. We finished. Many of them will be doing a mistake, like whenever we finished here, they will be returning true. No, that's what the mistake I personally done also. Okay, so here you want to check whether S1 is empty or not. Yes, it is not empty, right? See here, whether it is a valid string. No, right? This opening bracket is extra. That's the same case here also. Now, what I'm going to check is whether in my S2, there is some index that comes next to me which has a star, which means I have in fourth index I have a open bracket. In future, in some other index, there is any star. If there is any star, then I'll be converting the star into close bracket. So I have a star at 6. So check whether 4 is less than 6, because after 4 only 6 is occurring, which means I can convert this into a close bracket such that they two will be making a pair. So from this I can tell you that I'll be popping this out and popping this out. Now S1 is empty. Whenever S1 is empty, I'll be returning true. Here. Hope you understand this approach. Still I'll be giving you another example so that you can understand this clearly. Okay. So see this example: open, star, open, close, again open. Okay, let us see this example. After this example, you can understand this entire approach clearly. So see here, this is S1 and this is S2. Initially, what is this? So 0, 1, 2, 3, 4, 5, 6. So initially, it is open bracket. So insert here. Again, it is open bracket. Insert here. Here star. So insert here. So again, open bracket. Insert here. Again, it is close bracket, which means pop it out. Again, here comes close bracket. Pop it out. Here comes what? Open bracket, which means 6. 6 is inserted. Now that's it. The index is exhausted, which means out of bound. Okay, it gone to the out of the range. Okay. Now what is my next step? I'll be checking whether 6 is lesser than 2. No, which means my star it is at the second index, but my open bracket is as the 6th index, which means whatsoever ever I put here, like whether it is a close bracket or open bracket, whatsoever, I cannot make that a pair, right? So here itself I will be returning false. Can you understand this? Fine. So tell me, what is the time complexity and the space complexity? So time complexity will be O of n, because we are using only these tags and pushing each and every element and popping it out, which takes a constant operation, and also we are just traversing the n times. That's the reason why it is O of n, and space complexity is also O of n. Okay. Now whether we want a stack. So the third approach is still more optimized. So third approach is without using stack. Okay, so this approach is difficult to come up with yourself, but if you solved as many as stack problems, then you can come up with this solution. Okay, so let me take the example. So this is the example, right? Now see here, whenever I am going from left to right, I want to ensure that my open bracket is maximum. Whenever I am going from right to left, I want to make sure my closing bracket is majority with help of this hash switch. Can you understand this? Like what I mean is, I'll be taking a balance variable as 0 initially. Okay. Now I'll be starting from here. So I'm going from left to right. So it is open parenthesis. So +1. Again it is star. Star means also do a +1. Again it is a closing. Closing means do a -1. Means here comes 1. Again it is what? Closing. So do -1. Now here comes opening. Opening means do +1. Again here comes opening. Do +1. Again here comes asterisk, which means also again do a opening, which means +1. Okay. Now here comes opening. So 4. Here comes closing. 2. Here comes again a closing, which means 3. 3. So again it will be 2 when I encounter here. Okay. So all these range of elements are not less than 0, right? Whatsoever the elements here, all elements are not less than 0. So I I can say that opening bracket is majority when I am going from left to right. Now let us go with the right to left. Okay, so see here, same example. Now I'll be taking my balance as 0 now also. Okay, and I'll be start traversing from right to left. Now here comes close. Whenever there is a opening, now only we will be doing a -1. Apart from that, we will be doing +1. So here is a closing, which means +1. Again, here is a closing, +1. Here is a opening, so do -1. And here comes asterisk, which means again +1. Here comes opening, -1. Here comes opening, -1. Here comes closing, which means +1. Here comes closing, again +1. And here comes asterisk, again +1. And here comes opening, which means -1. So here comes everything. Here everything are not less than 0. So from these two conditions, I can tell you that it is a valid. Can you understand this? So the logic is simple. Like when I am going from left to right, I will be encountering the opening bracket first. Then only I want to encounter the closing bracket next. Whenever the opening bracket count is greater than the closing bracket, then I can tell you that it is like one kind of validation. When I am going from right to left, then I can tell you that always the close bracket comes first, then the opening bracket. So close bracket should be a majority. So take for example, I will be taking another example, which will be a false condition. So I have taken here, right? Opening, star, opening, close, open. Opening, star, opening, close, open. So this is what the given statement, right? Now 0, 1, 2, 3, 4, 5, 6. Now in the given string, I will be just going from left to right. So balance will be 0 initially. Now here it is a opening. Opening means I will be doing +1. Again opening, do +1. Again it is asterisk, do +1. Again it is opening, do +1. Again it is, but now it is closing, do -1. Closing, -1. Again it is opening, do +1. Okay, so these all elements are not less than 0. Okay, again now it's time to go with the opposite fashion. So balance will be initially equal to 0. Now at first I'll be at this point. So here it is opening. Opening means what it means? -1. So do a -1, which means at first itself my answer is what? It is -1, which is lesser than 0. Here itself I can tell you that it is false. Can you understand this? Yes. So this is going to be the optimized approach, and time complexity will be O of n and space complexity will be O of 1, because we haven't used any auxiliary space called stack. Yes. So this is going to be the optimized approach. Now let us see the code. So see here I am using a Java code. If you want a Python or C++ code, just go and search in my description. Okay. So see here, first of all, here I am using a recursion. So return check of s, 0, 0, 0. So this is going to be the recursion call. Okay. Now here is the check function. Okay. Here is a function call, not a recursion call. I mistakenly told like that. Okay. Now here comes a function. Okay. In this check, there will be a string s and the index I, and then opening bracket count, and then closing bracket count. Now if the I is the current index is equal to the s dot length, then I should return what? Whether the opening bracket and the close bracket are same, count is same. Okay. If it is not, then it will be returning false. If it is so, it will be returning true. Now if any of the time open is lesser than the close, strictly lesser than the close, at that time I will be returning false. Okay. Else what should I do? I'll be just taking the character at that particular index, and I'm checking whether that character is equal to the opening bracket. If it is an opening bracket, then I'll be going to the next index, and opening count will be +1 and closing remains same. If it is a closing bracket, then I will be going to the next index, opening remains same, but close will be +1. Okay. Else asterisk means I want to do for the all three combinations, and I'll be taking the OR operation of these three combinations. Can you understand this? So this is going to be the entire recursion code, and if I submit this, it won't submit. it won't get submitted because it is 3 power n. So that's very, very huge. Now let us go to the next approach. So the next approach is using a stack. So here I'll be using a 2 stacks. Okay, one stack is for open and close parenthesis and another stack is for star. Okay, now see here, I'll be traversing each and every element in the S, and I will be taking the characters from the S and storing in CH. Now if CH is equal to the open parenthesis, then I'll be pushing it into the stack. Okay, which means the open parenthesis, the stack which stores the open parenthesis. Okay, now elif if CH is equal to the close parenthesis, then I will be checking whether my stack is not empty. If it is so, I will be popping it from the stack. Else I want to check whether my star is not empty. If it is so, I will be popping out from the star. Else I will be returning false because I don't have any openings in front of me, but I am a closing. So at that case, it will be returning false. Can you understand this? Now else, so it is not a opening bracket, it is not a close bracket, then it is a star. So I will be pushing it into the star stack. Okay, now after doing this, I want to check whether my stack is not empty and also my star is not empty. Then I want to check whether my stack top is greater than the star's top. Then that itself I will be returning false. Else I will be popping each and everything. Okay, so because see here, when my star is lesser than the stack, which means I have a star before the opening, that doesn't make sense, right? Because if I put a closing bracket instead of star, here is a closing bracket, here is an open bracket, no purpose, right? So that's the reason why I will be returning false here. Okay, and at last I will be returning whether the stack is empty. Okay, after doing such operations, and then I will be returning if the stack is empty only, it will be true, else it will be false. Can you understand this? Okay, now let us go to the next approach. So this is going to be the approach that doesn't use the stack data structure. So see here, first of all, I'm taking the balance as 0 and I'll be traversing in a left to right fashion. Okay, and I'll be, whenever there is a closing bracket, then only I'll be subtracting 1 from the balance, else I'll be adding the 1 to the balance. In any case my balance is lesser than 0, then that's why I will be returning false. Okay, similarly for the right to left also, but the only difference is whenever there is a opening bracket, then only I will be doing a balance minus, else I will be doing a balance plus, and at some point my balance is less than 0, then I will be returning false. Otherwise after doing these entire loops, I will be returning true. Let me submit this. First of all, let me comment this. Let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts, just comment below. I'll be commenting the answers. Thank you.